Yeah, from the last two classes, we have started with Newton's laws. Like first, we have started with inertia concept. So that is tendency of an object to continue its state of rest or motion, and which is again correlated with the Newton's first law. Newton's first law is also called as law of inertia. We understood about inertia of rest, motion, direction. I hope you have gone through this inertia of rest, inertia of motion, inertia of direction examples. And then momentum is to be understood. A mass in a motion is called momentum. And mass into velocity. Whenever the body is in motion, it has some velocity. So mass into its velocity will be considered as momentum. So these are the examples. Hope you have learned. You have done these examples.
Sir, I have some doubt.
Yeah, please. Please, Agni.
Sir, from this assignment, number 8, 9, 10, no, 9, 10, 11, and 12, I cannot do.
Number
9, 10, 11, and 12. Sir, not here. Sir, not here. In the assignment.
okay, in the assignment, na? Okay, I will come to that.
Yes, sir. 9,
And
10,
next, Newton's second law.
12.
Newton's second law, like we have understood the rate of change of momentum. First, we understood momentum. Then, change of momentum is nothing but final momentum minus initial momentum. The next, rate of change of momentum. It's with respect to time. Rate means with respect to time. Okay. So rate of change of momentum is m of v minus u by time. Okay. And v minus u by t is nothing but a, and that, so mass into acceleration is equal to force. So it basically gives you the definition of force, Newton's second law. And we understood F is a vector, SI unit is Newton, CGS unit is time. There's a relation between Newton and dyne, and that based on that also we have done one assignment. This now we have I have given homework. Only few of you have sent it. Okay. Please send the remaining all of you whoever have not sent. By today you send. In this, what is your doubt, Sagnik? Sagnik?
Sir, I cannot solve question number 9, 10, 11, and 12.
9, 10, 11, 12.
Yes, sir.
Sir, I have doubt in number 9 and 12.
Okay. Okay. Let us discuss those first. So ninth one, kg I have given. So you have to convert it into grams. Okay. First this 1375 convert it into standard form. So which is nothing but 1.375 into 10 power
4.
huh?
10 to the power 4.
10 power 3.
Number 3.
The next in grams if you want to do into 10 power 3 you have to do. So 1.375, 10 power 3 is already there. So 10 power 3 into 10 power 3. What
10
is
power
the
3 is
value?
6.
Over 6.
10 power 6.
Right.
So this is the answer in grams. Then next, force is given, mass is given. So acceleration you can find out. Acceleration is nothing but force by mass. Okay.
Force.
So acceleration is equal to F by m, which is equal to 100 by mass 1.375 into 10 power
Yes.
3. Okay. So you have to simplify this. Numerator 100 is there, denominator 10 power 3 is there. So in the denominator, one more 10 will be there if you cancel it. 1.375 by 10.
Sir, 1.3.
So which is nothing but 0.1375. You will get acceleration as 0.1375. Okay? Is it okay, Sagnik?
Yes, sir.
Then next you got in meter per second square. Convert it into centimeter per second square. So centimeter, if you want to convert into 100, you do. So into 100, if you do, that the answer will be 13.75. Okay? Is it okay?
Yes, sir.
Then next,
Sir, dying will be 10 to the power 7.
that's it. 10 power. This is 10 power 2. 10 power 2 into 10 power 5 is nothing but 10 power 7. That's it. In this, what is the doubt? It's a regular processor. Then can you do Saknik 10 and 11 now?
Sir, just a
Saknik,
minute.
now can you do 10 and 11?
Sir, 12.
Is it okay or still I have to tell Saknik?
Sir, I think I'll be able to do number 10.
Huh?
Sir, I will be able to do number 10.
Then number 12, 11.
Sir, number 11 and 12, I have to see.
Then again mass they have not given. So mass is equal to what? Force by acceleration. That's it. So force is given, acceleration is given. So you can do it now.
Sir,
Acceleration is given meter per second square, force is given in Newton. So 1500 by 55. That is the mass in kg. Once you get mass, then convert it into grams. Easy only.
yes.
Is it okay or any others? Do you have any other doubts?
Sir, why you have given that arrow?
Huh?
Sir, why you have given that arrow?
Arrow is it is showing
That is
this
cursor.
cursor. Is it okay? Remaining, can you do?
Yes, sir.
It is very simple.
Sir,
F is
the
equal MA
answer
means
gram
if I
is
give F is
coming
equal
3
MA,
by. Sir,
yeah, yeah.
Sir,
Tell
the
Sakni.
answer in gram is coming 300 by 11.
Can you be louder, please? A bit louder.
Sir, the answer in gram is coming 300 by 11.
No. Do not tell in fraction. Tell in decimals. Tell in integers. Do not tell in fraction. 1500 by 55. How much? First of all. It's nothing but 27.27 kg. Then if you convert it into grams, into 1000. So 27270 is the answer. Or in the
Yes.
standard form, if you write 2.7, 2.727 is equal to into 10 power 4. Okay.
Oh, sir.
Then here this is 5500. Then here it is 1500 into 10 power 5. It is nothing but 1.5 into
Verse
10
7.
power 8. Okay.
Yes.
Sir, it is 15 or 1.5. Sir, in dyne, it is 1.5 or 15.
15 is greater than 10, na? That is not standard form, na? Are you
Okay,
getting,
sir.
Sarnik? This
Yes, sir.
1500, you have to write 1.5 into 10 power 3. Okay. So this is the standard form. 1.5 into 10 power 3 is the standard form. So into 10 power 5, if you do 1.5 into 10 power 8, you will get. Okay. See, if I give F is equal MA, that means I am giving
Yes.
not only one formula, F is equal MA, I am giving 3 formulae. That is, F is equal MA is nothing but M is equal F by A, or A is equal F by M. These two formulae also derived formulae, you should think of it. Are you getting my point?
Yes.
So you should think of
A
two derived formulae, that is mass is equal to F by A is equal to F by M. So this kind of formula also you have to derive and then use it in the calculation purpose.
Yes, sir.
Yeah, next to 12. 12 first you convert it into meter per second square, that is 55 by 100, which is nothing but 0.55. Or in the standard form, if you write 0.55, which is nothing but 5.5 into 10 power minus 1. Okay. Now you got acceleration in meter per second
Sir,
square and force is also there.
so 15
So then mass is equal to F by
5.5.
A. Then
Yes.
1500 by 5.5 into 10 power minus 1. Okay, then you simplify this, you will get the answer. Once you get this in kg, you will get it in grams. Easy only. These are all easy.
Sir, 1500 by 5.5 into 1
10 power minus 1.
or 10 to the power minus 1. Okay, sir.
Okay, you have to simplify this. Is it okay or any other doubts still?
Sir, can we convert this 1500 into means into standard form?
Yeah, you can convert 1.5 into 10 power 3 by 5.5 into 10 power minus 1. Then also you can simplify, or finally after you get the decimal also you can convert it into standard form. Once you simplify, after you simplify also you will get some number. No, that number also you can convert it into standard form. That also gives you the correct like answer only. Is it okay?
Yes, sir.
Sir, please excuse me.
Huh?
Sir, in number 10, how will I find the meter per second square?
First you see mass in grams is given, F is dynes in given. So acceleration you find out first centimeter per second square. Acceleration centimeter per second square you find out. F by m you do. 100 by 1375. You will get some value.
Yes, sir.
100 by 1375. Then after getting that, you divide it by 100. Then you will get in meter per second square. Is it okay?
Yes, sir.
You will get some value here, 100 by 1375. Then after getting that, you divide by 100 so that you will get mean meter per second square. Okay? Shall I go to Newton's third law? Oh, sorry, some more examples are there we have to discuss. Then again, we shall. After that, we shall go to Newton's
Yes.
third. Hope you are clear with this assignment.
Yes, sir.
Yeah. So let us discuss some more examples. A force of 10 Newton acts upon a block towards right, and a force of 5 Newton acts upon a block on the same block towards left. Okay. So 10 Newton you are applying rightwards and 5 Newton you are applying leftwards. So what is the net force beta?
Sir, rightwards 5 Newton.
Yes. 10 Newton rightwards, 5 Newton leftwards. So net force is 10 minus 5, that is 5. And right side. Yes, very good. Find the net force on the block and how much force should be applied and in which direction to produce an acceleration of 1 meter per second square. Okay. So net force you got it as 5 Newton, and first you take rightwards acceleration as 1 meter per second square. Okay. First you take right side. They didn't mention whether right side it has to be 1 meter per second square or left side it has to be 1 meter per second square. So we have to take both the cases and we have to solve both for both cases. How much force should be applied and in which direction to produce an acceleration of 1 meter per second square. So let us say first let us consider right side acceleration is 1 meter per second square. Okay. Net force we have already learned 10 minus 5, that is 5 Newton, and mass is equal to from the force and acceleration we can get the mass. So mass is equal to F by A, which is nothing but 5 by 1, which is nothing but 5 kg. So if you want 1 meter per second square acceleration rightwards, net force should be 5 Newton and mass should be 5 kg. Then you will get the acceleration 1 meter per second square rightwards. And if you want the acceleration leftwards, 1 meter per second square, okay, then what we have to get? We have to get a 5 Newton leftwards net force. Okay, so they are already applying.
Okay.
So in the previous case, we understood that if we apply 5 Newton of force, net force is if 5 Newton is there on the 5 kg mass, then the acceleration will be 1 meter per second square. So left side if you want 5 Newton, so that left side acceleration you will get 1 meter per second square. Okay. Then 10 Newton they said that right side they are applying it. So left side how much we have to apply? You have to have a 5 Newton net force. Right side 10 Newton you are applying. Net force is given as F net is 5 Newton. So what should be this force? This question mark?
15. 15.
Huh?
15.
Yes.
Or it can be 5
It
also.
should be 15 Newton. 10 Newton right and 15 Newton left. 10 Newton right and 15 Newton left. So net force is 5 Newton. So 5 Newton force is left side net force. Then you will get the acceleration also left side only 1 meter per second square. So that is what we have written in this document. In order to have a net force 5 Newton towards left, we need to apply 15 Newton towards left, so that 15 minus 10, which is equal to 5 Newton, and which gives you 1 meter per second square acceleration. Okay.
Okay, sir.
Which gives you 1 meter per acceleration left side. Any doubt here? The next question. If no force acts on a body, then what will happen to it? It changes its shape, it continues to move but with less speed, it changes its direction, it can either remain at rest or continue to move in a straight line with uniform motion. So it is just a Newton's first law.
Oh.
Newton's first law only. In a different words we have given. So option D is the answer. So what is the Newton's first law? Until unless you apply the force, okay, then the body which is at rest only, the body which is in uniform motion only. So that is what Newton's first law. So that is only here it is given. The next 15th. Ram is carrying a book in his hand. Name the forces acting on the book. Discuss why the forces acting on the book do not bring the change in its state of motion. Yeah, please think about it. I'll give you 2 minutes time. For example, you are carrying a book. What are the forces acting on it? Okay.
Sir,
Carrying a
gravitational
book. What are the
force.
forces acting on it? And if forces are
Sir,
acting, why
gravitational force.
why there is no change in its state of motion? Yeah, please. Shivangi, you are telling something? Can you tell me what are the forces acting? Can anyone?
Sir,
Yeah.
hello, sir. Muscular force, gravitational force, frictional force.
Muscular force, gravitational force, very good.
And normal force.
Normal force. Okay. Forces acting. Muscular force, gravitational force, air resistance force, frictional force between the hand and the book enables us to hold the book. Okay. Even though these many forces are acting, there is no normal force beta, Somyajit, because it is not kept on the table or any other platform. So there is no normal force. Somyajit. Okay. Uh, so why there is no change in the state of motion even though these many forces are acting? Because the net force acting on the book is zero. Net force acting on the book is zero. So that's why there is no change in its state of motion. If the net force is there, then we would have told that like there will be a change in state of motion. Okay, beta. Is it okay?
Okay, sir.
15th question. 15th question. Is it okay?
Yes, sir.
So what is happening? All these forces are balanced. So that's why net force is zero. Okay. Next, a car of mass 1500 kg is moving with an acceleration 4 meter per second square. If this car pulls another car of mass 100,000 kg, find the acceleration produced. Find the acceleration produced in the system. Please try for this. Try for 2 minutes. 2 minutes you try and later on we will explain. Yeah. The force applied is 1500 into 4 because mass into acceleration. And but this force is applied on 2500 kg mass, total mass. So 6000 by 2500. So acceleration will be 2.4. Devarga 2.4. Okay. The 6000 Newton is applied on 1500 mass plus 1000 mass. To 2500 kg mass it is applied. So acceleration would be, acceleration is equal to force by mass 6000 by 2500, which is equal to 2.4 meter per second square.